Okay, guys. Hey, welcome back. Nate Webb here, Blazing Illuminations. Hey, have you ever been walked into a place where you're going to do some service repairs on a lighting system or a sign system or audiovisual system, and the place is just a disaster? Like you walk in, you find wires all over the place. You open up a cabinet, and it's just a rat's nest of nastiness with gear you've never seen before, things you don't even understand, and none of it's labeled. None of it has any ID. No cable paths, just tangled rat's nests of nightmare. You ever been in a situation like that? Well, I'm going to tell you today, it doesn't need to be like that. It just takes a little bit of design work and planning up front. And I've got a bunch of different stories about how to do that. So, hey, join me on today. We're going to talk about a quick way to do some better wiring. How can we make better wiring work in our systems? How can we figure out how to put together systems that actually make sense and are easy for us to fix and repair and service? And maybe the guy that was designing the thing in your shop before, he was all excited about coming in and making it happen. But then
uh, what ended up working or didn't work was, he split. He left. He built out the panel, did the design work, made the whole thing work, and you guys deployed it. Everybody was happy. Client was happy. Everybody's happy. And then you got to go back for a callback, and you walk over there and you're like, oh my gosh, what was going on here? Open up that cabinet, tangled nightmare of cables going to all kinds of different locations, in and out of the box, up and down, left and right. Nothing's on strain reliefs. It's like, oh yeah, we did this before we started making our stuff better, and now we got to figure this all out. I wonder if I can get a hold of Joey, because he doesn't even work here anymore. Maybe I can ask him a question. Hopefully he left on a good terms, right? So you can even call him back. Oh my gosh. I don't know how many times I've been in that. So on my bench today, I've got a couple of different things. I don't actually have an example of, really nasty wiring. I could show you guys some pictures, but maybe my clients wouldn't be that happy. But I think we all know what we're talking about, right? You walk in and it's just like tangled nightmare of cables and no labels. I'm here to tell you there are systems that can help us make that work. We utilize DIN rail systems. We utilize different kinds of what I would term in my shop and on our studio when we were building things, I call it cable porn. And the reason for that is just because it looks amazing and it's awesome. And it might even get you excited. But yeah, so cable porn. So let's talk about it. I've got an enclosure here. We can switch over to that next box. This is just a big 16 by 12-inch enclosure. This is a fiberglass reinforced enclosure that I'm going to be deploying out on a big art piece here in the next few days. If we look inside of this thing, kind of tilt the mic out the way a little bit here, but we look inside of this guy. This is a simple little enclosure that I'm getting ready to send out. It doesn't have a whole lot of crazy parts and pieces, but it's going to do a lot of amazing things, right? So, in here, one of the pieces has fallen off the rack rail, but so in here, what you'll notice is everything is mounted to these rails. So I have three different rails. These are all called DIN rails. These are a 35 millimeter rail. The rail is designed to hold devices. And there are lots of cool devices to hold equipment like this or this. They actually attach. I think the box is actually upside down, but they attach and click in to the box just like that. So they'll stay on the rail. They'll be held in place. And this maybe isn't the best example of cable porn, but like this gives a good example as to why things are labeled. Uh, Cables are cut short to the specific locations and where things are going. So I'll just give you a brief description real quick on how this box is. So up here in this top corner, we'll have the power input side. So this is where the line voltage is coming. This would be line voltage right now because I've got it color coded as green, white, and black. I'm typically bringing in 120 volts single phase. Sometimes, well, not even really single phase. This is just one hot, so it's not even a single phase setup. A lot of times I'll also have a red or even a blue in here, so that'll give me three phase. If I do that, sometimes it'll be three phase 208, other voltage is that, but this one is just bringing in 120 volts. It's going to power one of those big transformer power supplies I showed you in the last video. I've got a service switch, one service switch. In fact, I'm probably going to add a second one to this one. So there'll be a second service switch in here when it finally goes out the door. So this is the line voltage input side. And then this is the low voltage input side. And I've got some DIN rail modules. They're similar to this, but these are double stack. So if you see, notice this one is just a single stack, and I've got a binder screw set in the middle. These are touchless screws. I can't touch or feel any of that, so I'm not going to get electrocuted by anything I touch here. And then I've got a double stack. So this one has a lower stack and an upper stack to make connections. I always use the lower as my negative and my upper as my positive in the DC low volt side. But I also have DC or DIN rail mounted fuses. And the cool part about these, and obviously if I had power to these, it would show it, but the cool part about these is these are designed to light up when the fuse trips. So if there was no fuse in here, or if the trip itself broke for overload reasons or whatever, all these little lights right here would light up. So these are fuse protecting the outputs off of this digital control system. This is just a really simple digital isolation amplifier for SPI TTL lighting system. So I can send the one signal that comes out of this guy right through here. It splits it 4 different ways. I'm only using 3 in this case. And then I'm fusing the power through. One of the things you'll notice here is power injection is also happening right here. The reason for that is that I do not need this device to handle any of the loading, right? So in all lighting systems, especially when it comes to DC voltage, we want to reduce the loading on all of our pixels or all of our LED systems as much as possible. And so we'll get into a video where we talk about distribution of power and power injecting on systems, because that's a super important piece. And power distribution, I would say, is probably the biggest issue across the board. For sign guys, if you've ever driven down the road and you see a sign just flashing, letters go out or they're just flashing. A lot of times that's due to cold weather, but it's also to power distribution is not done properly. So what happens is, in power distribution, you want to make sure you power it from a couple of different places. And a lot of times we get nervous that you can power it from multiple power supplies and multiple locations at the same time. It is possible, and I can show you systems and ways to make that happen. But we're talking about cable porn and wire porn right now, so this gives you good ideas to how to lay this out. So DC voltage comes in here, AC line voltage comes in here. All of my controls, my DC power is actually powering this device. And then because these two devices are the controls, I can actually backhaul my voltage, my low voltage, to power this device from here off of this same wire. So this box right here, in its best case scenario, it's just processing signal, and it can probably maybe, I would say probably half of an amp or something like that, maybe less. And then the same with this control box here, it's taking like half of an amp or less to power it up. So the LEDs in the strips, that's where we're going to see a lot more of the load. So downstream, I output my SPI signal down to these. I've labeled all my SPI1, SPI2, SPI3, so they coordinate and correspond with these outputs on this box. From here, I'll distribute out through similar cables as this down to my SPI pixel sets. Depending on how I load this, I believe I can go up to about 55 to 60 feet before I need to power inject at my strip. I believe that also by power injecting here, we'll be able to boost the signal, the power signal, to get to the strip. So I'm going to do some testing here on this particular system. The requirements are my power supply has to live about 60 some feet away, and so I don't want to get in a situation where I end up having to power inject back up inside this sculpture that it's going to go onto. So I'm going to do some testing with that, but this is how I lay that out. So I have my SPI protocol outputs here, and then if you notice, there's a separate jumper. This guy runs to these 3 here. This system, and this is where it gets really cool, is I'm going to run control digital pixel LEDs on LED strips, but I'm also running some DMX fixtures. So rather than having to have 2 different controllers, my one controller system here is outputting DMX for the lighting controller, or for the DMX light fixtures, and then also sending the SPI TTL protocols through this splitter out to the strips. So I'm able to program all kinds of fun stuff into this one sculpture. So it'll have in-ground lights blasting up at it that are all DMX in-ground light fixtures, and then it will also have the SPI pixels doing all their dancy chasey stuff up inside the sculpture as well. So this is a good example. It's not maybe the best, but it's a pretty good example as to how to break down what I would call interior closure and enclosure cable wire management, and making sure that everything's locked down and not just rolling around inside of here or a bunch of wire nuts everywhere makes service on this, which will happen. I don't care what anybody says. You could build the most bulletproof thing in the world. You will always end up servicing an enclosure. And if you don't do it, somebody else will. And I guarantee you that guy coming in behind you is going to be like, what the HE double hockey sticks is this crap? Like, don't piss off that guy by being that guy when you build your enclosures. Make sure you take pride in your work and you build nice looking, easily identifiable stuff. And here's one of the things that I think is really kind of the rant side for me. Anyone who is building systems and thinking that you're the only one in the world that knows how to do it, I guarantee you you're not. There are at least a million, maybe even 10 million or more other people in the world that know exactly what you're doing. I'm sitting here on YouTube talking about it. Do you think I think that I'm the only guy in the world that knows how to do this? I'm not. There's a lot of other people that are doing this. Maybe not everybody's on YouTube talking about it. But like, we need to get away from the industry where we all think we're protecting our business by making garbage, putting out garbage into the wild. We need to make sure that we're putting out high quality stuff, even where only a technician or someone else will see it. This is how the excellence of everything we do in our life, even behind the scenes. I mean, this is biblical. This goes back to biblical. Like, what you do in the shadows is what represents you in public. So do your best work even when no one else but some other random technician, or best case scenario, yourself, when you go walking back into this enclosure 2-3 years from now, you labeled it for yourself. How amazing is that? Let alone another guy, right? Don't be that contractor that, I walk into a job site and I see a complete disaster in an enclosure, wires going everywhere and all over the place, and I'm like, are you kidding me right now? Like, how did this guy get paid to come in here and do this? How did the client let him leave the building with this kind of stuff, other than he was hiding it and trying to act like nobody would notice, and trying to act like, well, somebody would open this enclosure and be like, oh my gosh, this is a mess. Maybe we should call the guy's phone number that's on the side. Yeah, how about this? That's the guy, the jackass, who did this project. Don't ever call him to do a wiring job again, because we're going to have to figure this out. Make sure that he never gets on this job site again. That's the way I look at it. So don't be that guy, right? Let's all be better. Let's all try to figure out how to make this whole thing better. Let's make everybody's lives better. You are not the only one out there making these things happen. They're not going to call you because there's a rat's nest of crap in your enclosures. They're not going to call you to fix it. And if you have to hire a subcontractor, this is where it really gets fun. Let's say you're a big giant AV company. Let's say you're a big giant sign company and you put out all this information. You go out and put out a job. You make this multi-million-dollar job. Some dude is going to have to come in and maintain it, right? Because if you put it all together, I guarantee you're having callbacks. I guarantee it. I can tell you a quick story. It's hilarious. There's a lot of people that might know this story. Hilarious story. It wasn't really hilarious for them, but they put together a whole gigantic sign display. Signs all over this building. Everything was crazy. And within months, they're already starting to get callbacks, warranty callbacks, like, this isn't where the client's paying you. You already got paid, and now you're having to go in and fix stuff. This system was so badly wired. They used the wrong wire. They didn't put their enclosures together well. Everything was just full of nasty crap. And so now they're all of a sudden getting callbacks. Well, they don't fly out. They don't fly the guy out that installed it. They hire a local. That guy goes out there, and he starts doing all his thing, and he starts finding loose wire nuts and weird stuff inside of enclosures. And without all the experience about understanding digital lighting and whether the company told him that or not, he got himself all confused and twisted up on, what is digital lighting? I put voltage and I'm not getting 12 volts or 24 volts or 5 volts, whatever it is. I'm getting all these random volts. So he wasn't even told what was actually going on in these enclosures. And so all he's finding is like loose wire nuts, literally, like little yellow rocket shaped wire nuts. I end up helping him out a little bit and finding out this is a digital system. Long story short, I end up fixing one of these things that was super complicated to get into. And because the system was so badly designed, so badly wired, and so badly put together, and I'll get into some of the details of this in some of our training courses and some of the other aspects of this, they should not have been allowed to touch wire. Whoever allowed that company to come in and do it, I hope that they were the cheapest guy. Because I look at the client who hired this group and say, man, I hope these guys were cheap. Because the work that they did and the performance they did and the output that they did was cheap. So by the end of it, because we had to do some really crazy stuff, that one little yellow wire nut, which I don't even have sitting here. You'd think I would on this crazy trashed out bench, but one little yellow wire nut, by the time my bill was done, was $20,000 to fix that wire nut. Hmm. Warranty too. Client didn't pay for it. Nobody else had to pay for it. They had to eat that out of warranty. So I don't even know if they were the cheapest. Do you think they had a margin that high? So at the end of the day, really, this is about saving our businesses. This is about providing excellence in our work that we do when we go out in the world. And this is about creating easy things to maintain. It will need to be maintained. And someone other than you, and maybe even you, will have to go back and fix it. So let's build it the best way we possibly can. If you guys are interested in more information about this stuff or want to get in with some of my training courses on how I'm teaching people how to build cable porn boxes, how to make wiring work, how to do power injection, what's digital lighting, LEDs, ins and outs, all those kinds of things, give me a shout. Like and share, like and subscribe. Let me know what you guys think about these videos. Give me some thumbs ups on them. If you guys are super interested, I'm just going to start cranking these out. So you might see 1 or 2 or 3 of these a week if I can get them out that fast. But yeah, I'm just trying to get the information out. I want to start building up the trades industry and really specifically identifying into LEDs, lighting systems, and how LEDs and data and computerized programmed LEDs, as this new wave of new LEDs are coming, I want to help be a part of that system and help you guys know what's going on. So, from an old timer to all the young guys, hey man, it's not as hard as that. It's a little bit of work. Don't cry. You'll be fine. Like and subscribe. See you guys on the next one. Thanks, man.